Hey guys, hope everything's going well. We're going to do another lesson here, 8.2 Law of Sines. Just a quick reminder that today I will be doing an office hour. I'll be doing it I'll be doing it on every Bronco day going forward. The office hour for you guys pre-calculus is from 12 p.m. to 1 p.m. It's on Zoom. The directions are there in the digital learning plan that I posted on Schoology. It's pretty easy to get on. I can share a whiteboard with you guys. We can do problems. We can talk about whatever you guys want to talk about. You don't have to stay the whole time. You can just show up for a few minutes, ask a question, and leave if needed. If you just want to pop in and say, hey, tell me what you're binge watching, that's fine too. It's kind of an informal office hour. So that's 12 to 1 p.m. We'll do that every time we have a Broncos day. Okay, so I posted some blank notes on Schoology again if you need to use them. We're starting with this problem here. Now, if we were in class, I would let you guys try this problem. And the trick is what I'm showing you is that this triangle is not a right triangle. Therefore, SOHCAHTOA, the sine, the cosine, the tangent ratios we've been using don't apply if it's not a right triangle. So that's why we need something else. And that's where law of sines comes in. So here's the law of sines. This is in your notes. You probably remember it from trig. Remember, the capital A's and B's and C's are the angles, and the lowercase a, b, and c are for the sides. So this gives us another option, a relationship between the angles and sides that can allow us to solve a triangle. And this is for every triangle, not just right triangles. This works for any triangle out there, which is kind of nice. Now, law of sines does work for right triangles, but if I have a right triangle, I'm using sines and cosines and tangents, and I'm using Pythagorean theorem. Those are just easier. So I would reserve law of sines for anything that's not a right triangle. Now, the trickiest part with law of sines is we have to watch out for these ambiguous cases. All right? Now, the ambiguous case only happens when we're given side, angle. If you remember back to Geo, that was the only relationship between sides and angles that didn't result in two congruent triangles. Okay? So that's the only time we have to worry about a triangle being ambiguous. Now, all that means, and I'll show you what it means to be given a side angle in a second. All ambiguous means is this. We have three options. Ambiguous kind of means vague. You really don't know what's going to happen. So when you use law of sines and you're given SSA, option number one, no triangle can be formed. That might happen. We'll see that in a second. Where the relationship between the angles and sides, it's just impossible to make a triangle. What also might happen is you can only make one triangle or two triangles. Okay? These last two options, 2 and 3, we're going to focus on those tomorrow, not tomorrow, but the next lesson. So today we'll just use law of sines. I'll show you what it'll look like when no triangles can be formed. And again, things are only ambiguous when you're given side angle. Okay? That's it. So let's look at this first example. So the first question I ask you up here is this thing ambiguous? So look at what we're given. The side angle and the angle side angle, if you remember all those combinations from Geo, what it's talking about is the order in which the angles and sides go. So when I look at this triangle ABC, I'm given an angle of 45, then a side, and then an angle of 40. So what I'm given here is angle, side, angle, right? In that order, ASA. So because it's not SSA, this is not ambiguous. Now, what that means, if something's not ambiguous, I'm going to have one triangle and one triangle only. I know that's going to happen. It's not vague. It's not tricky. It's going to be one triangle. All ambiguous means is that you might have one triangle or two triangles or three or no triangles. Okay. Today we'll only see when none happens. Next time we'll see what it looks like when you're given SSA and only one triangle works or two triangle works. Okay, so it's not ambiguous. So here's how law of sines works. We are looking for angle C, side A, and side B. So what I can do here is I can right away find angle C, right? Remember we talked about last time all three angles have to add up to 180 degrees. So that's pretty straightforward. This should be 95 degrees, okay? Now when you look at these three fractions here in law of sines, you're only going to use two of them at one time. You can use the first two here. Let me kind of erase this for a second, right? You might use these first two and set up a little proportion. You might use these for last two, the second and third one. You might use the first one and the last one. It just kind of depends on what you're given in the triangle. So here I now know that angle C is 95 degrees, okay? So you can see I have angle C and I have side C directly across from it. That's going to make up one nice fraction. So sine of 95 degrees over 4 is one part of my fraction. Now, because I know angles A and B, it really doesn't matter which side I solve for next. So let's just go alphabetically here. Let's do side A. We know angle A is 45 degrees, and we're looking for lowercase a down there. And that's a setup. Here, we can say cross multiply. Technically, that's not the best math term, but that's what we're doing. What we really do is multiply both sides by the denominators to have those reduce. But a shortcut is that cross multiplication technique. So I'm going to multiply these two guys here. Right, 4 times sine of 45. I get 4 times sine of 45. And I'm going to multiply these two guys here and put that on the other side, that on the other side of the equation. So I get a sine of 95. Now because I'm solving for lowercase a, I'm going to divide both sides by sine of 95. So I get 4 sine of 45 degrees over sine of 95 degrees. And guys, like always, I'm not touching the calculator until the very last step, right? I want to avoid rounding. I don't want to write a decimal a bunch of times. So now I'm going to go to the calculator. I'm going to type that in. If you type it in, you should get approximately 2.84. So there's side A, 2.84. All right. Now, for side lowercase b, we still can't use Pythagorean identities, Pythagorean theorem. We can't use sine, tangent, cotangent. It's not, sine, tangent, or cosine. This is not a right triangle. So I've got to set up another law of sines little equation. Now, I'm going to go back and use the sine of 95 over 4 again. Because you know A, you could use the angle 45, angle A, and the side that we just found. The reason I don't like to do that is because a rounded side A, 2.84. I want to be as exact as possible, so I know side C is exactly 4, so that's why I'm using angle C and side C again. And now I just have to find side B. So sine of 40 degrees, should have little degree marks up there, over side B. And from there, it's pretty much the identical setup. Cross multiply and solve. You might be able to kind of do that in your head. It's going to be B would equal, it'd be 4 times the sine of 40. Then you would have to divide by the sine of 95. And again, if you type that into your calculator and round it, you'll get 2.58. So 2.58 is my other side. Box those real fast. All right. So that is law of sines. Now, this is going to be a little bit more complicated next time. We start working more with ambiguous, but all ambiguous means is you might have 0 triangles, 1 triangle, or 2 triangles. Okay. Let's try another one. Take a few seconds here. You can pause the video even and try to answer the question whether or not it's ambiguous, and then try to set up a law of sines equation and solve. Go ahead. Okay, so hopefully you paused and tried. Here's what we're given. There's an angle, there's a side, and there's a side. Now remember, the order of that is important. Because we're given an angle, then a side, and then a side in that order, yes, this thing is ambiguous. So we got to be a little bit more careful, okay? Be careful. It's just not, this doesn't happen. It's not ambiguous when you're just given 2 sides of an angle. For example, if I take that 4 and I put it over there, that is not an ambiguous triangle. In this triangle here, I'm given a side, then an angle, and then a side. This is actually SAS, and it's not an ambiguous triangle. I wouldn't have to worry about any of the tricky, weird things happening, okay? But because in the order I'm given, it's angle, side, side, spells the bad word, this is an ambiguous triangle, okay? So let's go ahead and try to set something up. Because I have angle A, I'm going to use side A across from us, so sine of 60 degrees over 4 equals, my only option here is now to try to find angle B. So sine of B over 5. Now you can notice one new thing here, as opposed to the last problem, is we were looking for an angle this time. But start off the same way, cross multiply. So 4 sine of b equals 5 sine of 60. Divide both sides by 4. You get 5 sine 60 degrees over 4. Now, just like we've been doing for the last few chapters, sine inverse both sides, and you get this, sine inverse of 5 sine 60 degrees over 4. Again, I'm not touching the calculator until the very last step. I don't want to keep writing those decimals over and over again, and I don't want to round too early. So take a second, try to type that in. Like I told you last time, we'll be in degree mode for this whole chapter. But when you type that into the calculator, you should see an error. That's okay. Remember, this is an ambiguous triangle. In this case here, this means no triangle possible. That's all that means. That's what I told you we were going to see today with the ambiguous case. No triangle is possible here. Okay. Now, if you're curious, here's a quick explanation why. Check this out. So that angle there, 60 degrees, that can never move. So those two sides are locked in. This side 5 is pretty big, right? It goes out there. So what happens here is side 4, right? It's smaller than 5. And what happens is side 4 actually probably stops there. It's not long enough to fill in that little extra space there and get all the way back up to side AB. Now, when we draw this picture, we don't draw these to scale. So we just sketch a quick picture, we label all the sides. But if you measured a side of, say, 5 inches, and you measure another side of, say, 4 inches, and you made this angle here 60 degrees, you would not be able to complete a triangle. That 4-inch side would be too short and it wouldn't get up to the other side. That's why no triangle is possible. Again, that will only happen if you're given an ambiguous triangle, ASS or SSA. It's the only time you got to worry about putting no triangle or 1 or 2. Every other situation of sides and angles, side, 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 angle, 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 all of those will make one triangle and one triangle only. Okay. Let's go ahead and try to apply law of sines now into a few application problems. We're going to skip example 3 here for right now. Check this out. So these are some applications of our law of sines, and we had a few applications of the right triangles, and now we're going to do a few applications of law of sines. Okay, so it says this: to measure the height of a mountain, a surveyor takes 2 sightings of the peak of the mountain at a distance of 900 meters apart on a direct line to the mountain. So these little blue things here, those are my surveyor. Those are my the little things he's going to use to look up at the mountain at. All right, so surveyors are those guys who stand on the side of the road and have those little, like, it looks like a telescope they're looking through. They're actually measuring angles when they look through those things. So he take 2 sightings. They are 900 meters apart. So you know that this distance right here is 900 meters. And by the way, this is how they measure the heights of mountains, right? There's no tape measure that can go from the ground up to the top of this mountain peak and measure it, right? That doesn't make any sense. So this is how someone would do it. So he takes 2 sightings, 900 meters apart. Okay, let's put 900 meters there. The first observation results in an angle of elevation of 47 degrees to the top of the mountain. So here's what's 47 degrees. His first observation was here, right? The top of the mountain's up there. So this here is, right there, is the 47 degree angle, right? It says the second measure results in an angle of elevation of 35 degrees. So that's this little angle in there. That's 35 degrees. Okay, this little angle in there is 35 degrees, right? If the transit, which is the little thing he looks through, denoted on my notes by those little blue marks there with a box on top, the transit's 2 meters high, we want to know what the height of the mountain is. All right, so the 2 meters is going to be a little trick at the end. All that means is that these little blue things here are 2 meters high. All right, we'll talk about that at the end. So here's the trick. We're looking for this height, right? We do have a right angle here. Problem is we don't have enough information to use sines or cosines or Pythagorean theorem or anything because we don't have this bottom side, right? We don't have this hypotenuse, so we're out of luck. Okay, So here's the first triangle we're going to mess around with. We do know stuff about this, right? So here's what we know. Let's take that little blue triangle. It's an obtuse triangle, and let's try to redraw it a little bit down here. Okay, so I'm going to draw it not quite to scale. I'm going to draw it like this so we can see it a little bit better. All right. All right, so there's the blue triangle, right? Now here's what we know. We know this angle in here is 35 degrees, right? We know this bottom side is 900. And now we know a few other things. Look at this little angle here, right? Look at the picture above. We know that this angle right next to it is, right over here, is 47 degrees. If you remember from Geo, those two angles are called a linear pair, and they add up to 180 degrees. So if the angle next to this bottom, this big one here is 47, we can do 180 minus 47 and know that this angle is 138 degrees, right? I'm going to draw the picture up here. That angle right there, add it to 47, it's got to equal 180. Now, because I have two angles in that triangle, the big obtuse triangle down here, I now know that this top little tiny angle, add 35, add 138, subtract those from 180. I know this guy here is 12 degrees. So just like that, I have all three angles in this weird looking blue triangle up here. Now, the reason I'm trying to find that something about that blue triangle, is so I can come over here to this red right triangle, right, and find the height. So I'm trying to mess around here. In order to find the height, the best side to find would be this hypotenuse, right? If I know the hypotenuse, I can go to that red triangle and use sine or cosine or tangent to find the height. That red side here in the top picture corresponds to this side down here. This red side down here is the hypotenuse of that right triangle. So that's what I'm going to try to find. I got a law of sines down here. Bottom triangle down here, this obtuse triangle, I can't use sine or tangent or cosine because it's not right. But I can set up a law of sines. I can set up sine of 12 degrees over 900 equals sine of 35 degrees over x, right? Just like the problems I did before. Cross multiply, divide by sine of 12, go to the calculator, and you should get an x value of 2,483. Okay. Now, that's not the answer. Remember, I'm trying to find the height of this triangle. So now I'm going to go back to that red triangle. All right, let's redraw it over here. Here's that red triangle. All right. I knew this was 47 degrees. I knew this was a right angle. I'm trying to find the height of the mountain. I know that the hypotenuse here from the law of sines I just did was 2,483. And now using this, I can find the height, just like we did on the last lesson. So sine, I'm using sine because I know the opposite. I'm looking for the opposite, which is h, and I know the hypotenuse is 2483. So sine of 47 equals h over 2483. Clean this up a little bit, and you get an h value of 1,815.9 meters. Okay, now look back at your picture. Here's the last little trick. We're 2 meters short. Remember, those transits were 2 meters tall. So the height, 1,815.9 meters, plus that extra 2 meters gives me a final answer. Height of 1,817.9 meters. All right. That little 2 meter, adding that 2 meter in at the end is just, making sure you really understand what's going on. Yeah, just a minor little trick there. Okay, let's try one more. So read this problem. It's in the blank notes. Go ahead and take a second, try to set it up. See what you can pause the video, try to set it up, see if you can't use law of sines and maybe sines and cosines in combination to find the altitude of the balloon, which is another name for height. All right, go ahead and pause it and try it. Okay, so here's what we know. We're looking for the altitude of the balloon, right? That's a fancy way of saying the height. So let's put it perpendicular. Remember from last unit or last lesson, whenever we're talking about height, you can assume 90 degrees. So we're looking for that h. Now, it says in the problem that these guys here, person 1 and person 2, are 2.32 miles apart. So 2.32 miles. Here's the number one trick you got to watch out for. You can't assume that those two, that the balloon is directly in the middle of the two people. It doesn't say that. And if you think about their elevations, angle of elevations, right? This is 28 degrees. This is 37 degrees. They can't be, the balloon can't be directly in the middle of them. They're not looking up at the exact same angle. So don't just take that 2.32 miles on the bottom here and don't just split that in half. You can't do that. All right? So we're looking for h. All we know is the angle of elevation, 28 degrees and 37 degrees. Think about it now, we can come up here. The next little trick is to find that top angle. 180 minus those other two gives me 115 degrees. All right. Now, I want to find the altitude. I do have right triangles in here, right? I have two of them, one on the left, one on the right. I'm just going to choose to use this one, okay? Now, if I look at this right triangle here on the left, I want to find the height. That's one of the legs. I can do that if I know the bottom leg or if I know the hypotenuse. All right, let's call it x up there. If I can find x, I can use sine and cosines and tangents in this black triangle here to find h. Okay? So to find x, I got to look at the big triangle, right? The whole thing, and I can use law of sines. I get sine of 37 degrees over side x because it's across from it. I know that's equal to sine of 115 degrees over 2.32. That's using this big triangle, right? The whole outside big triangle there. So that's the setup for law of sines. Now, same techniques that we've been doing all day. If I use that and solve for x, I should get an x value of 1.54, right? And now I can come down here. Let's redraw it so you guys can see it better. I'm going to use that left side right triangle, right? I know that the hypotenuse here is 1.54. I know this angle is 28 degrees, and I'm looking for my height. No trick here adding. I don't have to add a 2 meters on or anything. I just have to use sines or cosines or tangents. I'm going to use sine. So sine of 28 degrees equals h over 1.54. If I solve for h, I get a height of the balloon to be approximately 0.72. Now, because my original distance was 2.32 miles, I know this height is also in miles. All right. So those are two good applications of using law of sines. You can see a lot of times we have to use multiple techniques, law of sines, and then a sine, a cosine, tangent, something like that. Your homework is 8.2 day 1. So go ahead and try those. That's on My Math Lab. Give those a shot. Come stop by the Zoom office hour if you have any questions on any of these notes, any of the past assignments, anything that's going on with these distance learning days. Just want to say hi, want to ask some questions, whatever. I'll be there for an hour. So, okay, talk to you guys.